Good day, Doctor. Now our Group 6 would like to present our group project, the prototype of 12-volt DC motor. Before I start my part, this is our group member details. And so my name is Kok Chi Zhang, metric number CN190152 from 2BNF, and I will present the introduction. What is CAD? CAD is computer aided design. Is to drafting, design, and drawing as word processing is to writing. And we, the student of course Computer Aided Design, are requested to complete a group project by draw a 3D model of an electrical component by using the AutoCAD software. And we took 12-volt DC motor as our title. And there is 3 types of motor, and the one we picked is brushed motor. Brushed motor is a type of motor produces a magnetic field in a wound rotor by passing an electrical current through a commutator and carbon brush assembly. The stator magnetic field is produced either by using a wound stator field winding or by permanent magnet. Generally, brushed DC motors are cheap, small, and easy to control. So DC motors are combined by 8 parts of component, which are front and back motor, front and back bearing sleeves, rotor, motor can, stator, and brushes. Therefore, we need to illustrate all the parts in detail in this project.
Hi, my name is Mrs. Zaika, so I'm going to continue by explaining the product background. So this is the diagram of our project. The most prevalent complaint about speed controls is that they are ineffective and unreliable. The efficiency aspect is crucial when it comes to saving money. The speed controller's efficiency is determined by the method control system. In the majority of situations, the speed controller is analog. DC motors are widely used in precision speed control systems like rolling mills, double-hull tankers, and high-precision digital equipment. It is important to control the motor speed in order to get optimal output. A DC motor is any motor that transforms direct current electrical power into mechanical power. Magnetic fields create forces that are often employed in this type of motor. Regardless of the kind, DC motors have an electrical or electromechanical mechanism built in. The speed of a DC motor is controlled by adjusting the supply voltage or changing the current intensity in the field windings. Hoists, elevators, and electric vehicles employ larger DC motors, whereas appliances, tools, and automobile components like electric car seats use smaller DC motors. A 12-volt DC motor is small and inexpensive, yet it is so powerful enough to do a range of jobs, because finding the right DC motor for a specific application may be challenging. It is important to work with the right company. For almost 45 years, MET Motors, for example, has been producing high-quality permanent magnet DC motors. One of the features of a 12-volt DC motor is its operating voltage. Last but not least, when a motor is powered by batteries, low operating voltage are typically preferred since they require fewer cells to provide the necessary voltage. Higher voltage, on the other hand, improve the efficiency of electronics used to drive a motor.
My name is Li Pei Wei. Now I'm going to talk about the objectives of our project. First of all, to design and develop 3D prototypes of the 2 pieces of 12-volt DC motor by using AutoCAD software. The second one, to generate each pieces by using accurate shape, size, and dimension used in a general 12-volt DC motor to get views about 90% correct. The last one, to generate clear views by drawing in SI isometric format as well as show the front and side of 2D orthographic drawing of each pieces of 12-volt DC motor.
My name is Natalie, so now I'm going to present on the methodology, which is the analysis of method to do our 3D drawing of our prototype. Before, the prototype of our group is a DC motor. So as we can see from here that this is the sectional part for the DC motor, which we split into 8 sectional parts, which we have the front and back motor can, front and back bearing sleeve, and then we have rotor, motor can, stator, and the brushes. So we categorize this execution part into 3 categories, which is the front category, the middle category, and the back category. So as you can see that the front and back actually they have the same part, which is the motor can and the bearing sleeve. So the first thing that I'm going to explain is on the front and back part, which I mentioned just now. We have the motor can and the bearing sleeve. So the motor can it functions as provide the protection to the component inside the motor. For the bearing sleeve, it can provide the oil film around the shaft to reduce and absorb the frictions. And also we can attach the component like gears, fan blades on the bearing sleeve. Okay, so the next part is the middle part, which is inside the motor, and then we can find there are 3 main components in the motor. So the first thing is the stator, which normally we call as the permanent magnet. So when we remove the cover and look inside the motor, we can find these 4 magnets, and then they will form a north and south magnetic pole. And then after that, we looking through the center of the motor, we will see the rod that is called a shaft, and then there's a rotor attached to it. So the shaft is used to convert mechanical energy from motor into the end use of application. And then while the rotor is a moving rotation electrical component that contains coil winding and powered by the DC current. And then finally, we will find the brushes which it will attach to the commutator as the bridge to deliver the electrical energy from the supply circuit to the rotor. Okay, so the tools that we going to do our 3D drawing is we use the AutoCAD software, and then the make technique we used during the drawing is firstly is the press pull, which it can form an area of 3D surface or the closed boundary as we select the 2D object. And then the second technique we use is the subtract and intersect. It can combine and remove the intersected region. And then lastly, we will use the union technique, which it can combine several 3D solid and surface into one object so that it's easy for us to move around or rotate the object. Okay, so that's all from me. Thank you.
Next is the design process of the DC motor. We divided into 3 parts, which are preliminary design work, 3D drawing, and assembler. Okay, before do the 3D drawing, we first do sketchings by list out and estimate how many sectional preliminary design works, and we divided into 5 parts. Every one members take one part and draw structure of the outer and inner sectional parts of the motor. This is an example of the stator and the brushes. Next, in order to determine the dimension for each sectional parts, we do some research from internet, and lastly we found in the Fusion 330 degree of the online gallery in the Autodesk. Next, the 3D drawing is the second part, where we use the software of the AutoCAD 2021. As mentioned above, we choose SE Isometric as a default view. Then we do draw the sectional 3D parts of motor in software and export out the model layout in the PDF file. Lastly is the assembling part. We combine all the 3D sectional parts and assemble them and make it a complete 3D model. The result of the assembled 3D DC model is shown in the result format. That's all from me. Thank you.
Hi, my name is Chong Yan Fang. Now I present how does our model part is assembly. So this is a 12-volt DC motor looks like. We have draw about 100.7 millimeter of a length and 98 millimeter of a height. So there are the shaft, front motor, back motor, motor can, and the stator, which always provides the stationary rotating electromagnetic field, and the rotor, which keep rotate due to the induced EMF. So for the rotor, as you can see here, there are many teeth, which actually is the coil winding place, and there is a commutator and brush. So this is a drawing that we have done. The front motor, motor can, back motor is actually what external of a 12-volt DC motor, and the rest of component is placed inside the motor, which are front bearing sleeve, back bearing sleeve, and the component that I mentioned just now, which are rotor, stator, brushes. So as a conclusion, AutoCAD is a powerful application for the computer drawing. For our group, we have done the drawing by using AutoCAD. So we have done the model using the 3D modeling, draw at the SE isometric plane, and export it. That's all from me. Thank you very much.